Adafruit would like to remind parents this Halloween to please carefully inspect your kids' candy. We found Doom running inside this Milky Way bar. Remember, do not eat if it's Turing complete.
Live from New York, it's Ask an Engineer.
Hey everybody, and happy Halloween-ish coming soon. It's me, Lady...
Every day's Halloween here.
Every day's Halloween. It's me, LadyAda, the engineer, with me, Mr. LadyAda. Camera control, audio control, and more. We're here at the Adafruit factory in downtown Manhattan. Behind us, this is the factory. As you just saw some video, this is where we do the kitting and testing and manufacturing and coding and videoing and photoing and documentation and shipping. All electronic goodies that keep us going. So if you like some of the ridiculous content we make, please pick up a kit or a component or a feather or more. We've got a packed show with a lot of guides, and it's not out yet.
Yeah, there's some new products that folks are going to really like. They've been waiting for a while.
I know. I've been trying to get to everything. All right, but let's kick it off, Mr. LadyAda. Why don't you tell them what is on tonight's show?
All right, on tonight's show, the code is high power. 10% off in the Adafruit store all the way up to 11:59 p.m. or when I remember to turn code off, gets you 10% off in the Adafruit store for everything we have in stock, and you still get free stuff. Lady will talk about that and more. We got some live shows. Talk about our Adafruit live series of shows, including Show and Tell, which we just wrapped up a few moments ago. Time travel, look around the world of makers, hackers, artists, and engineers, see what's happening. We also have a really cool segment this week with Retro Tech, looking back in the world of electronics and more. We have from the Mailbag your letters to us, some help wanted. It's from jobs.adafruit.com. We also have some Made in New York City factory footage that you'll be able to check out here from Adafruit. 3D printing, some cool projects from Noah and Pedro. We have Ion MPI this week. It's from Epson. New products. Lots of top secret this week. We answer your questions. We do that on Discord, adafruit.it/Discord, where you can join all 35,000 of us. There's a few thousand people online right now. Put your questions in the chat. We get to them at the end of the show, but lots of folks will help you out in between now and then as well. All that and more on, guessed it, Ask an Engineer. Okay, let's pay some bills. First up, use the code. And when you use the code, you'll notice there's things you can put in your cart, and they're free.
Yes, the new products of the week are 10% off. And you also get freebies when you order from the Adafruit shop, because we love our customers and want to reward you. At order $99 or more, you get a free Promo Proto half-sized breadboard, handy for making your projects permanent from a solderless breadboard. $149 or more, you get, it's still happening, the pink circuit board PCB KB2040. It's an RP2040 microcontroller board with 8 megabytes of flash, buttons, STEM QT, USB-C, castellated golden pads. It's great if you have a Pro Mini project or Pro Micro project and you want to RP2040ify it with a lot more flash and RAM. Runs CircuitPython, MicroPython, and Arduino. Ooh. $199 or more free UPS ground shipping for your entire order in the continental United States. And $299 or more, we still have Circuit Playground Bluefruits free with your order. It's got buttons, it's got LEDs, it's got buzzers and switches, and it's got a Bluetooth Cortex M4 processor that can run. You can do some MakeCode stuff on it. We got, I think, MicroPython, CircuitPython, Arduino. People have ported Rust and other platforms to it. It's a great way to start your solder-free project. You can even make Liz's Bluetooth-controlled bat project she just posted. You can add BLE control to it. All
right, we do a bunch of live shows every single week, every month, every year here at Adafruit. Our live shows, including the ones that we did today. We had Show and Tell. Lots of folks came by, and you can see what their projects were. A couple of highlights. Phil B showed some of the makings of the Milky Way Doom bar.
Chocolate Doom.
Yeah, so carving the actual vessel for the electronics out of a candy bar. Does it work, or do you need to 3D print something? You can tune in and find out. That's on all of our places we post video, like YouTube and Twitch and all that. And we had DJ Devin stop by showing some cool API projects with CircuitPython. And then Mark had some really neat pumpkins, including a Blinka pumpkin, which is super cute. So thanks for coming by.
And eyes.
Yeah, it was really neat. On Sunday, we do From the Desk of LadyAda, and this is where we have it, a show that we do in 2 parts. It's whatever is on Lamore's desk at that moment. It's almost like there's this social media app, like it's like The Now or something.
Oh, the Be Real?
Yeah,
I don't
Be
know how
Real.
it works, but I always see like funny
it's like
shots
right
of-
now you have to do this. So
Oh,
whatever's
it's like
going
the anti-Instagram. It's,
Yeah.
You can't Photoshop it.
No, you're just like whatever's happening right now, you just have to show you, and you have to be honest about it. So
Okay.
what we do is we just turn the camera on and we're like, what's on your desk?
Yeah, so this week I was a lot of tests. First off, I showed off, I tried to make a tester with these strip pogo pans and totally failed. So I showed that off because I thought other people would like to learn from my not complete functionality working projects. I also showed off the TPS 601040 boost converter we're going to get in the store. I showed off a stemma motor driver. And then the big project I showed off is, we've had these Teensy 3.6 base testers that we use for programming all of our microcontroller boards, like sensors and little power breakouts we use in Arduino. But if we're running SWD or mass storage or USB, we have to do something more advanced. We used to use Raspberry Pis, but actually, like Raspberry Pis, they eventually have issues and they take a long time to boot. And so we've started using solid state, in situ SWD programming, and we use a Teensy 3.6, which was wonderful. Unfortunately, you can't get Teensy 3.6s anymore because of the chip shortage. So we decided to redo our entire tester with an RP2040 Pico, and also we made a couple other updates while we were at it to sort of like fix some things and add some more features. So we're gonna have to, port our libraries over to the RP2040, but it's a chip that there's not been any shortage issues with it, and the Picos are inexpensive. So if they do get blown out, because sometimes the tester, gets damaged, it's very easy to swap out a RP2040 in exchange. So, hopefully the PCBs will arrive. I'll put them together, and then I'll show off that tester in a week or two. Some people were really into this. We got good feedback. People really liked seeing the behind the scenes, what is the pan that the chef uses.
Well,
not just
a lot
the
of
recipe.
the folks who watch Desk of LadyAda, they run their own little electronic companies or big electronic companies, and they want to keep up on how you can test electronics. There's the designing of, the manufacturing of, and then the testing of. It's almost usually it's like separate departments, separate people.
Yeah.
LadyAda kind of does
It's just all in my head.
a little bit of everything. Then we do the Great Search, and the Great Search is when Lady uses her powers of engineering to help you find the things on digikey.com. Thanks, DigiKey.
Yeah, so this week, because I was working on this tester, what I wanted to do is we used to hand assemble all these testers. And they were all through hole, and that's okay, but the thing is that we're probably going to have to make these brain boards that then are used to control the device under test board, which is separate. We're going to have to make like 50 of these because it's we're almost out of TNC 3.6s, and I'm probably going to go back and redo some of the older testers with this new tester. And so I was like, let's just put it through the pick and place machine. So I wanted to find a surface mount. Everything else I could find surface mount: the SD card holder, the sockets, the connectors, the TFT, FPC connector. The thing that I didn't have yet was a surface mount USB-A connector, because again, I've always traditionally used the through-hole version. So in this Great Search, I find a couple really good options for USB-A, and I show you the differences between them.
All right. And then we have JP's product pick of the week. We do that on Tuesday. And then Thursdays we do a JP's workshop. But let's check out JP's product pick of the week this week.
Is the NeoKey 5x6 Ortho Snap Apart PCB. This has socketed key switch receptacles, so you can take your key switches, you don't need to solder them in, you just place them into their little sort of spring-loaded clips there, and now it's ready to go. That is collecting the column and row presses and then sending key press and key release messages to the microcontroller, and then I'm also sending it NeoPixel color changes. So when I press one of the green ones, it turns pink. When I press one of the pink ones, it turns green. So that is kind of helpful feedback that you can use, especially when you don't have printed keycaps, just to keep you oriented with what you're doing. NeoKey Snap Apart Ortho 5x6 PCB.
And again, don't forget JP's show is tomorrow, Thursday, JP's Workshop. And then Friday, we have Deep Dive with Tim, Funny Guy. Tim stopped by and showed a really cool trivia game that you can build with CircuitPython, and he'll be showing this off on Friday as well. Time travel. Let's look around the world of makers, hackers, artists, engineers, all the things that are going on, including some company news, things in the news, and more. So first up, November 8th is voting day, and at Adafruit, it's a paid day off.
Yay!
So let me do what I do every single year, and I'll just mention it. I know
It's not too late, everybody.
I know this year is, midterms, and there's a lot of things going on. This is, a U.S. conversation. But next year, 2023 and then 2024, every year when voting comes around, a lot of people get angry on Twitter, and they're mean to each other on social media, and they talk about change, and they talk about which hashtag you're using or how you update your profile picture. Here's my suggestion. Ask your employer what it would take to get paid day off for voting. Companies should allow folks to vote. Usually it's part of the rules and stuff like that, but a lot of people don't. It's not convenient no matter what state or federal laws are, and maybe their employers are not doing the right thing. But if we had it as a day off, a lot of people could volunteer as poll workers. They can get involved. They can be more civic minded. And so wherever you fall on the political spectrum, it seems like this is something that would be kind of good. We've been doing this for years, and my suggestion is just ask your employer. Just be like, hey, what would it take for us to have this as a day off? Because usually if you come in a different way and say, we demand to have this day off, that's one way to do it. But usually you can figure out a way to negotiate and say, like, hey, like, what would it take? Like, what is there a metric that we'd have to do? Is there a way that we could do our schedules or something? Because this is an important thing. Like I said, maybe for some folks this year isn't that important, but pretty sure upcoming years will be pretty important. And there's a few companies that do this in the maker world. Every year I send out emails and I say, hey, would you consider doing this? Some have. So I will continue.
And this is separate than the legally mandated requirement.
Yep.
This is we give the entire day,
Full day off.
so that way you don't have to come in at all.
Full day off. A lot of
and you can
people-
volunteer, and you can do more than just vote.
Yeah.
You can actually help other people vote.
Yeah, well, we wanted to do this because some folks want to help out and make sure the elections are fair.
Yeah.
And you need poll monitors and more. So we can talk about this, and we can try to dunk or like say you should do this, or we could just set a good example. And so that's what we're trying to do. If little old Adafruit can do it here in New York City, you can do it too. Okay. Next up, I wanted to mention that if you haven't seen it already, we played in the beginning of the show. We have the Candy of Doom, the Turing Complete. If it's
Chocolate
Turing Complete, don't eat it.
Yeah.
You can. It's made the rounds all over the internet.
Phil B did a great job with this project. Jepler
Yeah.
and Phil B collabed on this.
So
Jepler did the code. Phil B did the video and the mechanics. It was a great collaboration.
So our promise to you, if it's something that can run Doom on it, we'll get Doom on it. So this is one of many projects that we hope to get out before, I guess, Doom is just in a pill.
Yeah, and then check out the show and tell where Phil B shows off the making of and how it was done. It really is Doom. That's an ESP32S3 running, a miniaturized Doom wad, but it does all fit into the 4 megabytes of flash and 2 megabytes of RAM. So good job again, Jepler, on getting that going.
Okay, and then tomorrow is Hack Pumpkin live at 6:30 p.m. with Ali, Kevin, and Jorvin. This is our friends over at DigiKey. These are the hosts. They do this every single year. I wanted to help get the word out. Happy Halloween.
Happy
And, go check it out. You'll see this on Twitter and all the places tomorrow. And then we'll probably be making our announcement next week, like I've been saying over the last couple weeks. Most likely, we are going to tell everyone that we did not get the 5,000 parts we wanted in time for the latest Adabox we wanted to do before the end of the year. But that just means we can for sure do all the Adaboxes we want to do in 2023. So if there's still a chance, but we'll let everyone know soon. You can always pause your subscription. We don't charge until it ships, so you could just let it ride. But if you want to bounce and then try to come back, you can. However, we have a few thousand people waiting to get on the Adabox list. So if you bounce off completely, you might have to wait to get back on. And part shortage changed some of our plans, obviously. A good example is, and I'm not saying this is the only reason, but if we were using microchip SAMD microcontrollers,
We wouldn't get it till 2024.
we wouldn't get it till 2024. So if we had any Adabox planned using those chips, maybe it would have been a good idea for us to use some of this time to redesign those Adaboxes using something that's more available, like an ESP, expressive base chip, or
There's the S3s are out. and
or
there's
RP2040s. So
Other
we could
chips.
probably guess a lot of the Adaboxes we're going to do. We're going to make sure we're not stuck waiting forever for something that's going to be forever moved and the football pulled away from us at the last second. Okay,
Yoink.
mailbag.
We get letters, we get tweets, and we get emails.
Okie dokie. These are some of the emails or letters or something we get from y'all each week. This is this week's mailbag. I teach a second-year college design class in electrical and computer engineering, and I want to give you kudos on your CircuitPython IDE and hardware kits. The well-supported design tools make it simple to build meaningful projects from the ground up without a huge time investment. Even though students are building challenging projects from the PCB level up, the success rate has been high. That's right. Imagine not being able to see your project work at all after spending months on it. Imagine
So
not
my
being
first,
able to...
my first internship, which I did at Mitsubishi Electric Research Lab, I literally spent 3 weeks just trying to make an LED blink on. It was a Philips. Sorry, it was an easy USB chip, and it was so frustrating.
Yeah, but
it was weeks.
You learn the
3
hard way. You cut your teeth on
It was like 2 to 3 weeks, and I remember when I got the LED to finally blink, and it was like, this is a mix. There's assembler and because you do the compiler and the upload technique. It was just forever, and I just don't want anyone to have to live through that.
I think
again.
there's a
I mean, it
debate-
was amazing when it got working, but
I
it was
think
so
there's a debate
painful.
about how or why that would be good or bad. On one hand, someone could say, well, because that was so hard, that's why you became the engineer you are, and that's why you wanted to make things easier for it, and that's why you pushed really hard to get all these skills to never have to do that again. The other side of this could be like, if you didn't have to waste your time with that, you would have got so much more done.
I couldn't finish
we would even be further along.
Oh my God, it was
Yeah.
such a pain. And I remember because he wanted me to use the advisor wanted me to only use open source tool chains, which is fine. But so I had no example code, no example compilation, no example uploading. So I had like 3 or 4 variables that I just couldn't control. But I did get it working eventually. But boy,
Yeah.
it was not fun.
So I think there's a couple ways you can look at it. You know, for you saw this as an opportunity to never do that again, and you spent the last 15 years making sure you never had anyone had to do that again.
It's been more than 15 years ago. But
I also hear people that are kind of cranky, and they're just like, well, everyone should learn the hard way, but not everyone can, and not everyone should, and not everyone has enough time.
it was really not. It was.
Yeah,
I didn't
anyways.
learn that much. I was just very frustrated.
Okay, retro time. Okay, so this week, not only do we have a piece of hardware from back in the day, but we have the commercial that came with it.
Yeah.
So here it is.
We knew they were coming. Futuristic computer minds, advanced intelligence, an electronic language of lights and sounds. But there's one thing we didn't know. How much fun they are! Touch Me! 3 different games in one where your family challenges each other and an unpredictable computer. Touch Me! Fun and action for the whole family, or just for one. Touch Me! The pocket-sized
Okay.
computer game from Atari. What will they think of next?
Yeah, not a great name. But look at this design. So this was a physical representation of an Atari game for arcades, and Simon came along, and I think they wanted to have some type of handheld game as well.
Notice that they didn't have any. They only had red LEDs. Otherwise, they would have had yellow, green, and blue. But
Yeah.
blue LEDs didn't exist yet.
Yeah, so
I think they
there's,
did
like-
have yellow and green,
Yeah.
but they didn't have blue.
Yeah,
Didn't have the GAN, in GAN.
very Simon-like. And like LadyAda said, when you don't have different color LEDs, you have to just put the LED on a colored square.
But look at they have the Atari switches. Those are the
Yeah.
remember from the Atari 2600 those mode switches. They are extremely satisfying and good looking.
Yeah. And here's some of the packaging. You can see.
Touch me.
Yeah.
Touch me.
3 whole games in one. What are you gonna what are you gonna do with all
It's
this?
like Pong, where they're
Yeah.
like we have tennis and hockey,
We have
and it's
3 entire games. Look, 1978. The times were simpler, and we scan in the manual, and we have all this stuff. So we're trying to do our best to preserve some of the computing history. This is a very weird device that not a lot of people heard about, and not a lot of people saw.
I never heard of this.
Yeah, and that is this week's retro. Okay, we have a jobs from the Adafruit Jobs Board. A bunch of jobs have been coming in. I'm just going to keep focusing on just
Great.
like one per week, but some other new ones came in. This is this week's. This is a STEM program instructor, full-time, White Mountain Science in Littleton, New Hampshire. If you want to be a STEM program instructor, check it out. You can look at the website, all the information about it. You can apply. We review all of these before we make them live, make sure there's not sketchy or scams or who knows. You can not only post your skills up if you're looking for a job, but if you're a company and you want to find cool people like these folks are, you can post up the job that you want to meet some makers to apply for. It's jobs.adafruit.com. Okay. Python hardware time. Okay. This week, couple little bits of news, and then we're going to talk about some other stuff. CircuitPython Beta 3.
And we're going to come out with Beta 4 soon. A lot of bug fixes. ESP32C3, I think, just got fixed in the latest. More Pico W fixes. Thank you, everybody who's been trying out the Wi-Fi and Pico W. It's been exciting to see it taking over. We'll be doing more projects as well.
So 8, Beta 3, and then Beta 4 is coming out soon.
Yeah, we'll see.
Before I talk about some of the other stuff, just a little bit of a reminder. So LadyAda did a chat last week.
Yeah. And I showed off CircuitPython.
Yeah, CircuitPython for Espressive devices, and all of the videos are now out. You can check out Espressive's first ever DevCon 2022, and they did a fantastic job. Kudos to the entire team over there who managed to put together a great virtual event with tons of stuff. I was watching lots of different sessions and more. So next up, Python 3.1 got released. Some people have been, keeping an eye on this. There's some performance increases and more. It's always good. Did our normal roundup of like which languages are popular right now. It's usually neck and neck with JavaScript and Python. And then it's Halloween time. So if you look in the newsletter this week and you're looking for some, well, there's still time, so I don't know if it would be last minute, but if you want to put some eyeballs on something, you can look at some of the videos from Show and Tell. You can look at some of the guides that we have. You can just type Halloween. You could also just type eyeball. We have a lot. And then the Pymaroni wireless kit, it's easy to program. It comes with this neat glass skull, and you can.
Oh,
program
really?
it
It comes with the
MicroPython.
skull?
Yeah, you can order it with or without skull.
Oh.
Yeah. And then here's a cool Raspberry Pi Pico MicroPython animated skull. Lots of skulls.
More skulls.
And, if you go through the rest of the newsletter, you can get all the things that you might need for Halloween or more.
Oh.
And then I wanted to show one last thing.
Yeah,
Our friend
go
Pete
up.
Warden
Go up.
introduced
Bam, bam,
a
bam.
people detector.
Yeah, this was actually kind of neat. So Pete Warden, who worked on TensorFlow Lite for microcontrollers at Google and is now, I believe, in academia, has been working on taking some of the ideas and concepts from the TensorFlow Lite for microcontrollers. I have to remember TensorFlow Lite for microcontrollers book and making it reality. So he always had this idea of having a person sensor that was extremely low power and low cost. And so he actually released it's a $10 sensor. It has a HiMax camera on it, and it has I2C and a microcontroller, and it's running TensorFlow Lite for microcontrollers, and then sends that data over I2C. So in this example, he shows how to use CircuitPython running on a RP2040 Trinky to communicate with this like all-in-one sensor to detect when a person gets close to a computer screen.
And one of the neat things is this is not connected to the internet. Everything is on the edge. There's no personally identifiable information that's getting transmitted anywhere. It's a person detector without taking you and putting it into the cloud where it never goes away, and one day it'll hurt you. So this is a neat trend, and it's neat to see folks putting this type of power in a microcontroller and then using all the open source hardware and software from Adafruit to make it all work together. I think if you're concerned about AI and you want to be someone who builds things instead of uses things only as a consumer, this is a neat one to consider. People detector. And then you can have all the smarts with CircuitPython to have it do stuff.
Yeah.
If it sees a person, then here's a
Right.
bunch of things you can do. Okay. That's our Python on Hardware newsletter for the week this week. Please sign up. You do that over at adafruitdaily.com. We deliver the newsletter every single week to your inbox. And over on Adafruit Daily, you can sign up for this newsletter and other ones that's not connected to your store account at all in any way. And that's how you know you're never going to get spammed from us. A little bit of a reminder, don't forget, codes high power, 10% off at Adafruit store. We are an open source hardware company, speaking of all the
Yes.
open source things you can build. We have 2,750
Six.
We
We got
guides.
over 2,750, which is a big deal.
Yeah, that is a big deal. So on the big board this week, LadyAda.
Okay. For known Pedro will show the video soon. They showed how to make these custom Halloween neon LED signs. There's the Grim Reaper, there's Hipster Ghost, and there's Werewolf Moon. Showing how to use the LED animations library and CircuitPython to create like pretty advanced animations that can run concurrently, which is really cool. I think they're running it on the RP2040, but it looks like neon, but it acts like a NeoPixel, which is kind of like the best of both worlds, and it's great for making signs. We see a lot of restaurants and cafes have neon signs that are made out of the flexible neon LED neon because it's like inexpensive and it's durable. People can't break it as easily, but they're not animated. So check out this guide from Pelly over at Microsoft Research Labs. There's a new feature for MakeCode. Well, it's like MakeCode-ish, but for Microbit V2, you can use microcode, which is like a block drag and drop system. It just came out, so I honestly haven't actually gotten to check it out. I just read the guide. But it's really neat. They're trying to figure out easier and easier ways to get people introduced to computing. So if you have a Microbit V2, check out that guide, follow along, and if you find any bugs or issues, let them know because they just released this.
More guides.
Kattni finished a guide for the LTR329 and LTR303 light sensors. We had Arduino and CircuitPython code, but we have a guide that talks about all the pinouts and details and how to use them. Both sensors are basically the same core. They have a visible and a visible plus IR diode, so you can read both channels. The LTR303 also has an interrupt pin, a threshold interrupt pin. So it's a little bit more advanced because you can set the interrupt, whereas the 321 is a lot simpler. We thought there could be uses for both. We're personally going to probably use the 329 for a future project, whereas the 303 I think is what a lot of makers would want in a breakout board. JP did a project on the TCA8418, which is the new keypad matrix driver that we put into the shop recently. The matrix driver lets you do 8x10 keys, but what he thought would be interesting is, a lot of people want to make split keyboards, but you end up having to do this weird RX-TX thing where you have two microcontrollers that communicate with each other. And he's like, well, with this matrix expander, there's two addresses you can pick for them. You can't pick two addresses, but the RP2040 has two I2C buses, so you can have two connected and you can have them separated but connected with just a basic STEM IQT cable. A lot simpler than this bidirectional communication. It just shows how to use our 5x6 snap apart ortho keypads to make a DIY ortho keyboard with that split and has the cable in between. But it's also a good example of how to use two devices on different I2C buses, on one RP2040 board, and how to make your own keyboard with a plastic case. And then Carter wrote a really handy guide. This was in our Blinka Raspberry Pi guide, but it was like kind of hidden and people didn't see it as much. There's still a lot of chips that we use that are require I2C clock stretching. I3C has removed clock stretching, and we totally understand why, because it's really hard to implement very well. The Raspberry Pi computers do not implement clock stretching, and so there's a lot of times people are getting weird data, sensors don't quite work, they start flaking out. There's a couple ways to fix it. One is tweaking the GPIO speed, and we show some examples of how you can figure out what GPIO speed works. You can also use BitBang I2C. The BitBang GPIO I2C driver for the Raspberry Pi, it's a kernel overlay, and that will definitely fix the problem because it is a software-based I2C. But there's trade-offs for that, because I think you can't use it with hardware drivers, and you have to wait till it boots. Trade-offs, whatever. Check it out. This could solve your issues with clock stretching devices on I2C on the Raspberry Pi. And then finally, Liz did a fun no soldering project for Halloween.
No video.
Oh, we're gonna watch the video with a flapping Halloween bat. Originally the code was just CircuitPython, and then today she added a make code page as well.
Looking for a quick, no soldering project for Halloween? Have no fear. This project gets you from zero to a flapping vampire bat in no time. You can build this animatronic bat with a Circuit Playground Express and 2 servo motors. The servos have alligator clips that can clip to the Circuit Playground pads. The bat's wings attach to the servo motors. CircuitPython code running on the Circuit Playground moves the servo motors in a flapping motion. The code also utilizes the LED animation library to animate the Circuit Playground's NeoPixels. To get flapping, power up the bat with either USB power or a JST battery pack. To see how you can build your own vampire bat just in time for Halloween, check out the Learn Guide at learn.adafruit.com.
All right, time for some factory footage. All right, it's time for some 3D printing. Let's go on, Pedro. We're going to play 2 videos back to back, and then we'll see on the other side. The first one's going to be those LED Halloween
Neon signs.
Decoration signs, and then a 3D printed jack-o'-lantern. That is a surprise if you're a Disney fan.
This Halloween season, you can 3D print your own LED neon signs. Bring these signs to life with LED animations using Adafruit's CircuitPython. Use multiple NeoPixel strips to create elements with spooky animated features. Print a hipster ghost wearing shades, a Grim Reaper holding a scythe, or a werewolf howling at the moon. Powered by Adafruit's Cutie Pie RP2040, this little devil packs lots of treats with features that are sure to fright. This 3D printed coffin snap fits together and houses a small perma-proto board. Perfect for letting your dev board slumber in peace when it's time to lay to rest. With CircuitPython, you can program your own LED animations and build custom sequences. Use the animation group helper to synchronize groups of animations and multiple pixel objects to create specific features. Get the spells and acquire the ingredients to build your own by traversing the Adafruit learning system. We hope this inspires you to bring your DIY frights to life with Adafruit's CircuitPython.
And don't forget, you can learn how to make all this stuff and more on 3D Hangouts every Wednesday with Noe and Pedro. Okay, before we go over to INMPI, don't forget, go to Type Power. 10% off Adafruit store. LadyAda, let's do INMPI. All right, this week's Ion MPI, brought to you by DigiKey and Adafruit, is from Epson.
Yes. This one is right on time. I don't have a lot of clock and time jokes because it's a precision RTC set from Epson. These RTCs, you know, what's interesting is I don't think of Epson necessarily as making chips and RTCs, but they are really famous for their crystals. We use Epson crystals all the time in our devices, and so it makes sense that they take something. This is basically a 3.2 by 2.5 millimeter crystal, and they're like, we're already really good at the crystal part. Let's shove an RTC chip in there, and they did. So we're going to feature the RX 8901 CE, but there's also the 4901, which is the SPI version. And basically this is, Epson's really good at crystals and temperature compensation for crystals. Now they've added a microcontroller, a silicon chip inside that acts as a real-time clock and is temperature compensated, which is really important because this is something that people ask us about all the time, is how can you have precision timekeeping? I think I was even looking, Jepler, who's one of our engineers, is like, I'm a time nerd. If you're a time nerd, you know it. You want to have the best, most accurate time possible. Turns out that's actually pretty hard to do. A lot of people have used chips like this, temperature compensated RTCs from Maxim, and I do love these chips, but I do want to mention that this is basically another option. So if you aren't able to get these chips because they've been really strongly affected by the chip shortage, or you want to try another vendor or something that's a little more affordable, this chip is a really good option. So as I was kind of looking into this, I was like, well, why is it so hard to do really accurate time? And I think one of the issues is that people have not misinterpretations, but they have experiences with clocks and timers around them that influence how they think time works with electronics. And there's actually a lot of work behind the scenes to make time very accurate that you're not even aware of. So even historically, if you had an alarm clock or a wall clock, it plugs into the wall. It actually uses the 60 hertz frequency of the mains in order to, because it goes 60 hertz here or 50 hertz in Europe, and it uses that to power a timer, a flip-flop and a clock divider, and then that's how it gets 1 hertz. And what's interesting is the 60 hertz is actually really good enough that you can have extremely accurate timekeeping, because that frequency is generated by the power plant in your town or outside your town, and they can synchronize it to make it like a perfect 60 hertz. If you look at this website, Leap Second, they actually did analysis. So during peak hours when there's a lot of power, actually the frequency kind of goes up and down a little bit. But at the end of the day, when the power usage is lower, the power plant will actually adjust the frequency back. Like they'll kind of like give you some extra cycles or remove some cycles, or kind of tweak the frequency so that on average it really is like extremely precise 60 hertz. Problem is that a lot of people don't plug into mains voltage anymore. Oftentimes you're using a switching power supply or USB, and so you don't have access to this like pre-calibrated 60 hertz signal that will give you like really accurate timekeeping. So a couple of options that people have used historically are, you know, a WWVB NIST radio receiver kit. So this is a radio transmitter that's, I think, in Colorado, in the United States, maybe a couple other locations. And if you have, you know, this radio module, you can receive that signal and it'll give you extremely accurate time because the transmitter is, you know, atomic clock accuracy. It's like it is the NIST timekeeper. The problem is that honestly, all the way on the East Coast here in New York, we never got this working really well. We always had a lot of difficulty, especially inside of an apartment. You really have to have the antenna either outside or, you know, pointing in the direction of Colorado or whatever in order to get good signal. Look, I bet if you're in Nebraska, you're going to get amazing signal. But we had a lot of trouble here in New York City. And of course, again, you can't have it be indoors. It has to be kind of outdoors-ish or near a window. Another way that people get accurate time is with GPS. GPS also gives you, you know, atomic clock precision. You have to face the sky with the antenna, but you know, once you get signal from there, you get the absolute accurate time. But again, it's kind of expensive, uses a lot of power. You need to synchronize with these satellites, and then, you know, finally, if you have network capability, if you can use NTP again, also. This is a atomic clock synchronized timekeeping service. But all of these things, you know, the 60 hertz mains is inexpensive, but a lot of people don't connect to mains anymore because they're connected to through a switching power supply. But the radio, the GPS, and NTP are all very power hungry. Like you need to have internet, or you need to have a receiver or a radio. And so while those are really good ways to keep your project synchronized really well, a lot of people want something that's standalone. And so when you use something like a real-time clock, you're going to connect it to a crystal. And usually it's a 32 kilohertz, 32.768 kilohertz crystal, which means that, you know, 2 to the 15th power times divider of the clock frequency, 32768, is 1 hertz, and then that's your 1 second timer. And the circuitry that does the dividing is perfect, right? Like it's very easy to make something that divides by 32768 because again, it's a power of 2. The problem is that the crystal itself has some variability. Even the highest quality crystals are going to have some variability of about 10 to 20 ppm, depending on the temperature, especially with temperature, but also just natural variability because crystals aren't, you know, they don't oscillate perfectly on time. You know, atomic clocks do, but they're, again, extremely expensive. So, you know, you get these crystals, they're 20 ppm, you do the math, 20 parts per million, ends up being, you know, you calculate there's 86 something thousand seconds per day, and, you know, multiply that by the 20 over 1 million, and basically it turns out to be 2 seconds a day of plus or minus loss. And over a month, that adds up to, you know, almost a minute. So it's like 2 seconds, you know, 1.8 seconds a day. But it can also be a little bit more depending on aging and if the temperature gets very extreme. So basically, you know, you're losing up to a minute a month, and that can be quite a lot. It's very annoying. It means you're constantly, you know, you have to synchronize your clock with, again, one of these atomic clocks. Or you can go with a temperature compensated crystal oscillator with Epson has. And what that does is it'll be able to cut it down from, you know, maybe 20 ppm to like 3 or even, you know, 2 ppm, depending on if it's commercial versus industrial temperature range. It's a little bit more expensive. You're adding in $1 or $2, but it's not as expensive as a GPS. It's not very power hungry. The circuit is, you know, does little tweaks here and there to get the oscillation to be much closer to 32.768. Or it'll add or remove pulses to even it out. So you basically end up getting closer to true 32 kilohertz signal. So this is this is what we've got here. It's a temperature compensated crystal with a real-time clock in it. There's 2 versions, I2C SPI. There's also 2 pin options, pin A and pin B. I think one has frequency out, the other one has more event inputs. But the interesting thing is the frequency tolerance. That's what you want to look at. So for the XS series, you get as little as plus or minus 3 ppm, which basically means plus or minus 8 seconds. It's about 1/10, 1/8 of as much variation in frequency over minus 40C to 85C, and then for very hot temperatures, it is going to be a little bit more than that. So above 85C, which again is very hot. It's not 85F, it's 85C, plus or minus 5. So this could be very good in hot environments where you want to get a better timing rate. And then there's an I2C version, SPI version. There's also all the RTC stuff you'd expect. The temperature calibrated frequency output, event input pins, so you can timestamp stuff without having to wake up. Separate battery and V out. Power supply can be 1.6 to 5.5 volts, so really nice wide range, wide temperature range. Auto switch from V out to V bat. Everything you want in your RTC, and it's temperature compensated, and the price is really good compared to many other temperature compensated RTCs. It's kind of like half the price. So quite nice.
Available on DigiKey, and it's in stock.
Yes, that's the best part. There's a lot of them in stock, both the I2C and the SPI version.
And usually, sometimes the companies have little sales videos and stuff like this. This is a little different. Epson has a really beautiful video that goes along with
this. This was so relaxing.
Yeah.
I felt so much better after watching this video.
This is really, really good. We rarely play, just here's a sales and marketing video. It's actually really nice. Epson did a really good job. So we are going to play it.
Maintenance は手作業になります。最終的にはミクロン単位の手仕上げ、これが要求されてきます。でそこはもう経験を積んでいくしかないんですけども、腕を磨いていくっていうのは何十年もかかる。ここは水晶デバイスに使われる人工水晶原石を作っています。特にセンサー関係に使われているデバイス、人工水晶は非常に高品質な素材を要求されます。一番短くて3ヶ月、長いもので6ヶ月育成しています。釜開けの時はですね、もう陶芸家さんと一緒でいつも毎回ドキドキしてですね、仕事をしています。素材が出発原料となりますんで、いい素材を作ると水晶デバイスのアドバンテージになると考えています。いい水晶を作るには原料、種水晶、釜、それと人です。何一つかけてもダメです。水晶は生きてます。
Wasn't that cool?
I promised I wouldn't cry during an MPI, but
no, I just it was so
yeah.
peaceful,
so,
and this crystal's so beautiful.
I've been doing this biz with you for a while. I've never seen a video where they go through and show the process of growing crystals like this.
I know. Actually, I didn't realize that I also thought they were mined. For some reason, I was I didn't think oh yes, of course they'd be grown.
You could grow them,
but they're beautiful. I mean, they're they're enormous and they're perfectly clear.
Yeah.
And yeah, I mean, it's they grow them for 3 to 6 months. So it's you have to have perfect cleanliness. Everything has to be temperature. Everything has to be set up to make these gorgeous, perfect crystals every single time. And they've been doing this for probably 100 years.
Yeah. Can we get a crystal growing machine around here?
I kind of want one now.
Adafruit
that
makes
thing
us-
is cool.
Yeah, can we get some of that government money to do a crystal fab?
I don't know. They're beautiful.
Yeah.
It's cool how you can tell like they get one big crystal and that turns into millions of little crystal oscillators that you guys
Anyways.
use in your circuit. So a little bit of every microcontroller board that you've ever made.
This is why we like doing Ion MPI, because we learn something new every single week.
I really didn't know how crystals were grown, and now I do.
that's this week's Ion MPI.
On MPI.
Okay, so don't forget the code is high power, and we're gonna go off and do some new products.
That's right. New.
This week
New.
we have a bunch of it's not out yet and top secret, so we're gonna do one new product and then we're gonna go
Yes.
and do
But it's a good one.
a bunch of stuff. So the star of the show this week, besides you, LadyAda, our community, our customers, everybody who runs Adafruit, our employees, our staff, our friends, our partners, is
This very high power infrared LED emitter. We were seeing a lot of people trying to build their own TV Gone type projects or IR controllers. And one thing that is I've learned about infrared transmitters is you really want to like drive them really strong to get good range. Like you want to hit the IR receiver even if it's not pointed exactly directly at it, 10 meters away, 15 meters away. To do that, you have to have a bunch of IR LEDs and you really want to drive them very strongly with a transistor. And so, we have circuits showing how to do that, but it's always like people have to get the FET and the pull down and the resistor. So I thought, let's make a little stemma board. You connect your JST PH cable on one end, I'll show that. Give it power, ground, and a signal, and then it'll just blast that to 2 infrared LEDs. I picked nice and bright ones. We chatted about that on the Great Search a couple weeks ago. I think these are 90 lumens, or I don't remember. They're as bright as the 5mm LEDs that we sell. You can drive them at 100 milliamp standard, 1 amp peak. On this board, if you give it 3 volts, you're going to get 100 milliamps per LED. If you drive it at 5 volts, you get 200, and I think that's really good because that way if people leave the LED on, you won't damage it and overheat it. But it's really simple to use. So I thought I just showed on the overhead real fast. And what's nice is that this overhead doesn't have, it has some IR cut filter, but not a huge one. So the board comes like this. There is a breakout area if you want to solder to it, but I really just recommend using one of our Stemma 2mm pitch JST cables. You get a on LED, which tells you that the board is powered, and then this signal LED will tell you when there's signal coming in on the signal line. The red and black are power. Again, 3 to 5 volts works great. When I touch this to 3 volt, you see the signal line, which is human visible. So I can see that red LED. These are not human visible, but they do come through on the camera because that's how cameras work. And they're really nice and bright. You get 2, 1 edge and 1 upright. And then if you happen to want, another LED or you want an external LED, we give you one more spot. You can just wire up a standard infrared 5mm LED. In this case, it's a white LED. But then you get one more blaster, and then you can always disable the on LED or the signal LED if you want it to be stealth mode. But just a little easy, inexpensive board with mounting holes just to get people's IR blaster projects going very quickly and very easily.
And that is new products this week. Okay, a little reminder, don't forget high power is a code. You can get all this free stuff. Please start putting your questions up in Discord. I already have some lined up, but this is where we answer the questions. Let's jump right into Top Secret.
Okay. We have a couple top secrets.
Did a preview on the socials today. These are the boards that we showed off. And, the names are on some of them, so you can see them. Scorpio is the name of the board. We have a cute little RGB glowy scorpion. And then we also have a feather floppy wing. And this is our rabbit friend that has floppies. I had a rabbit named Floppy when I was a kid. And then this is the official logo of the floppy wing. But what, LadyAda, are these boards? What do they do? Show them off.
Well, starting with the Scorpio, this is an RP2040 board. And it actually it does dual duty. There's two things that you might want to do with this. One, it's, your standard feather, with USB-C, and this is a prototype. It's not going to be green in the end, but, prototypes always come out not black necessarily because it takes a longer and more expensive to get black prototypes. And at the edge, where normally would have like an SD card slot or something, we have 8 I/O pins that are going through a level shifter. And this level shifter takes the USB input and gives you, 5 volts to the level shifter. So it shifts 8 of the GPIO, and they're in consecutive order, to the output. And the idea here is you could use the NeoPixelate library, or any other time you want to bang out 8 bits at a time in parallel, and especially if you want to have them level shifted up to 8 volts. Good for NeoPixels, but there's probably many other use cases as well. And there's also a little STEMMA QT port up here if you want to connect sensors. And then the rest of these I/O pins you can just use as a plain feather. So it's also an everyday feather. Okay. And on the back, the direction and the voltage, I didn't label them, but one is you can change the voltage output from 5 volts to 3 volts, and the other one is you can change the direction. And the reason you might want to do that is you can also use this not just as a 8-pin output, but 8-pin input. So if you want to use this as a logic sampler, you can do that as well using PIO, because again, these are 8 pins that are in consecutive order. So you can use PIO to read 8 bits in a row. So, for, people do a logic analyzer project, or if you're doing data capture, you can use this, and then it has a buffer. So even if you have 5-volt signal in, it would level shift it down to 3 volts for you.
Scorpio. Okay.
It's like a happy little scorpion.
Yeah. All right. Next up, what do you want to show?
Next up, I can show the floppy feather wing, because I finally did that revision.
Hop on by.
So we've actually done a bunch of work to make floppy interfaces for Arduino and CircuitPython. I just got super distracted with a lot of part shortage stuff. So getting back to this, so this is what's really neat is a 2x17 header is exactly 1 feather wing wide. So this is for your standard floppy IDC connector. I also give you 5 volts from the USB if you happen to. It doesn't recommend it to power a floppy drive from USB. Actually needs more power than a USB provides. But, you might be able to do it with some low power floppy disks. And then on the bottom, we have the level shifters, because floppy disks are 5 volts input output. And so this would do the level shifting from the 3 volt floppy. From the 3 volt floppy. Hold on. Focus. This doesn't want to focus. Hold on. It's a little bit too high up. Or too low down. Let's try now. Beautiful. 2 level shifters that will take the 3 volts from the floppy, convert it to 5 volts and back. And then there's also a little 5 volt little mini boost converter that will let you take the 3 volt logic level to make sure you have a really good clean 5 volt logic. And then the write enable pin, with the write protect pin, we have a switch on it. So if you are doing floppy archiving, you want to make sure you absolutely never even accidentally write to the floppy drive. You can simply short the write enable pin high permanently, or low, whichever one I can't remember off the top of my head, by setting the no write versus the write OK direction. So that'll be good for floppy reading and archiving. So we have the code for this in Arduino and CircuitPython already. This is just
yeah, and you're probably wondering, why in the world would you want to do anything with floppy disks in that old tech? Well, one of our friends, Neil, had the original Prince floppy, which is a piece of history. This is when Prince changed his name, formerly known as Prince, is a symbol. Here's an article on Hackaday, but you could see this. We had to figure out a way to get this off, and we had an original PowerBook, but that's not going to last forever either. And so there's a lot of things that we want to archive, and put somewhere in, this is our history of computing for the last, it'll soon be like 20, 30 years. So we wanted to have something for people to be able to read and write floppy disks from all types of computing, and hopefully put it in a more permanent place where more people can share and access it. Okay, and then last up, LadyAda, what's your last
Okay, so
thing
last
you
up,
wanna
I've got, we had all these people making cute little boards with 5x5 NeoPixels. And I thought, I'd make a little add-on that you can just kind of attach to the back of your Cutie Pie board. And, this, I want to try to do this just by, press and holding it.
Yeah?
Yeah.
You did it.
Yay. So, yeah, you can solder it directly.
Yeah.
And then, it doesn't there you go. So if I tilt it, so you get, 5x5 NeoPixels, so you can have little messages or animations displaying, and then you can use it with, your ESP32C2 or S2 or S3 or this Cutie Pie or an RP2040 or whatever, or a Seed Shao board. It's just a little add-on. You just plug it to the back, and now you can make a little glowy, rainbowy friend.
Okay. And that is this week's Top Secret. Lots this week. Okay. We're going to jump right on to the questions. Are you ready?
Yeah.
Okay. I have a bunch lined up.
Cool.
Ready?
Yes.
Here we go. First up, would you consider making a 5-volt 3-amp power bank breakout board? I know I want to make my own power bank to replace my 3-amp one and be perfect.
This is the person who asked this question like a week or two ago. The answer is still we don't have one. Really, if you want to replace an existing power bank, you should get another power bank.
Okay. In the Python newsletter, you showed a third-party camera by Useful Sensors. Do you plan on carrying that camera sensor? I see they have an apparent collaboration with SP. Maybe that's... just wondering if you also get the board since you sell the microcontroller featured.
Well, they just came out, and we are chatting with Pete Warden about it. Right now, they're having a little difficulty getting more made. I don't know if you knew about this part shortage. So we can't stock them quite yet, but we're chatting and we're giving them some suggestions. Yeah. And hopefully they'll be able to get
Once we're able to, you should assume yes, and we'll have a pack that comes with a Trinky or other things, and maybe we can do a discount when you buy them together. I'm really excited about this because Pete was at Google, and now he's able to run an electronics company, and I think he's going to be able to do a lot of stuff that he wanted to do at Google, but now get it out maybe faster, sooner, and more open because it's, academia.
Yeah.
Next up, have you done long distance testing with the IR sensors at 1 amp?
No, because I wanted to drive them at 100 or maybe 200 milliamps for this board because I'm expecting people to not be as careful because, you can just connect it up to anything. But it should be able to hit, a couple meters, 10 meters.
Okay. I know it's too late for this season, but any thoughts about re-releasing Halloween boards with round screens? I damaged my Adabox Halloween display, it seems. Yeah.
Sure.
Yeah, what we want to do is, continue to ride out this part shortage, and then we have a bunch of ideas for all different shapes and sizes of a lot of the boards that you like. Different shapes and sizes for mag tags, different shapes and sizes for hollowing. Eyeball projects with round eyes. You name it, we want to do it. Any idea when we will have more magnetic USB cables in stock?
They're on order, but I don't know exactly when they're coming in.
Okay. You have a few GPIO expansion quick boards. Thoughts on a GPIO Pro version? This one having mini, I guess that's MOSFETs for each GPIO channel. Uses idea would be automated lights to music with coding, sequences, timing, Christmas lights, etc.
It's a good idea. Probably not for this Halloween or Christmas, but maybe next year.
Okay. Question: what has been the primary limiting factor in the production of the BN0085 boards?
There's no BNO 085s.
The essential ingredient.
The essential ingredient. So we do have BNO 055s in stock right now. I would really recommend using those. They're almost completely identical for most usages.
Let's see. I think I got most, if not all, the questions. Yep, there is still a part shortage going on. Those are the questions, LadyAda.
Okay.
Good job. All right, everybody. Thanks so much for joining us this week. Special thanks to Jessie May, who's running things behind the scenes in the Adafruit Slack. Thank you, Jessie May, helping out our customers and our team and more. We'll see everybody next week, same time, same place. We thank you so much. Please consider using the code, saving $1 or $2 on the way out. You get the free stuff. This has been an Adafruit production. We'll see everybody next week. Here is your moment of Zener.
Thanks, everybody.
Bye.